There's three things that I love. I love working with technology. I love working internationally, and I love leading teams. I found quantum computing, it's been almost a decade ago now, and I saw an opportunity within the quantum computing space to start a different kind of a company. When we first started in quantum computing, it was like the early days of computing in general. There was no supply chain. They had to build everything in-house. They couldn't count on anyone outside. But since about 2020, we've just seen the supply chain and this ecosystem begin to flourish.
We moved here to the United Kingdom in June and have been residents in Milton Park in the Bee House for several months, starting in, I think, October, and then just opened this facility last month. We don't make components, we don't make software, we bring the components together, and our magic is we have the engineers that know how to make these things talk to each other, because some of these components we're putting together have never been put together in the way that we're doing that before. Traditional computers operate in a binary fashion. It's either a 1 or a 0. With qubits, quantum bits, we look at very subatomic particles that operate in superposition, which means they can be in multiple states at the same time. When you measure that state, it can be any number between 0 and 1. It can operate a lot faster when it comes to solving things that are optimization and things that are simulation.
Modeling molecules, modeling chemistry is something that classical computers really struggle at. In fact, we have huge companies that have to have wet benches, like actual chemists mixing chemicals, just to understand what will happen if you mix those things together in these conditions, etc. And essentially, the reason it's so hard is because nature is not classical, it's quantum. And there's all this extra quantum information that you can't efficiently represent in a classical computer, but a quantum computer can very well effectively mimic those interactions, and it has the same scaling and it can capture those problems much more effectively. So we see a lot of use cases around materials, around chemistry, and those kind of things as well.
This technology today is not better than what we have, but we see where it's going. We think drug discovery, for example, can go from around 10 years to about a year, which means revolution in healthcare.
We don't ever see outgrowing Milton Park. There are so many different facilities here that we can expand into as our company grows. Fantastic infrastructure as we scale up to more data center-like operations. We anticipate needing power, low latency bandwidth. All of that connectivity is right here in Milton Park.